Welcome back. It is a I'll be back with a good problem. The problem is there are four strings, identical strings of length L, connected by a spring horizontally with a force constant K, and it is a block of mass M is attached to it. Now when we displace this block, it executes simple harmonic oscillation. Now what is the angular velocity and the time period of oscillation of this block? Now see here, when it makes an angle theta symmetrically between the two strings, here it is 90 minus theta. At that condition, initial case are at an angular displacement theta. So here 2t sine theta is balanced spring force, and in upward direction here is also t. Here is also t. It also makes an angle of theta each. So upward is 2t cos theta is equal to mg. From two equations we can write tan theta is equal to fs by mg. And here for at an angular displacement 30, now here tan 30 is 1 by root 3 and numerically equal to spring force is kx. Initial separation of the rhombus is 1.5 L, and here when it makes an angle of 60, its final separation is L. So elongation unit is only L by 2. So from this equation we get m by k or k by m. Now, so for this equation kl by mg is equal to 2 by root 3. At C, for example, it is y. The total value of y is L sin theta plus L sin theta, 2L sin theta. On differentiating once, delta y is 2L sin theta delta theta. And for horizontal separation it is a small amount x plus x 2x, and here the total value will become 2L sin theta. Now after differentiating, delta x is 2L sin theta, derivative is cos theta into d theta, and here 2 delta t sin theta. And for small additional displacement of this block y, when we displace this block a small amount y, delta y from equilibrium position, in this case 2t sin d theta is equal to kx, and from this equation delta t is equal to k delta x by 2 sin theta, and here k by 2 sin theta. In case of delta x we can write 12 cos theta delta theta, and from that part we can write delta theta is, here is dy by minus 12 sin theta. And here after simplification, when this block is displaced, there is a restoring force upward direction. That restoring force is minus 2d dt cos theta. That is, restoring force is minus ma, and it will becomes, you can write it as delta t, means this is the amount has to be substituted, and here and cos theta once again. By simplifying this one is as delta y, put the value of delta y from this equation here, and by substituting this one is m, by bringing this m and delta y, here cos by sin is one more cos theta, cot theta into cot theta, cot theta, and k by m from this equation is G20 by root 2L cot square 30 and dy cot 30 root 3 under square means 3. After simplification, minus 2 root 3 G by L delta y. By comparing with standard equation, now omega is equal to under root of 2 root 3 G by L, and time period is 2 pi by omega, and after solving 2 pi into root of L by 2 root 3 G. So it's a good application of simple harmonic motion and are based on the restoring force. Thank you.